Hi class, this is Dr. Karsten, and today we are doing lesson 14 from module 5, grade 4 of EngageNY Math. And today's lesson has actually a pretty complicated title. It is, Find common units or number of units to compare two fractions. Basically what they're saying is that we're going to be comparing two fractions to determine to figure out which one is larger and which one's smaller. And we're going to do that by having numerators that are the same size or by having denominators that are the same size. Another way to say that is a common numerator or common denominator. When something's common, it's what we have in common. So that's what we're going to be doing today. Now, before we get started, I just want to remind you that I posted a lesson that talks about tricks about comparing fractions less than 1. You must have watched that video before you watch this one because it really goes into what we're going to be doing today, and it'll make it much more clear. So if you haven't watched that, I'm going to put a link to it in our Google Classroom. I will put a link to it in this lesson in the description. So please make sure that you watch that. So again, I entitled it Tricks. I can't remember the exact title, but it did say tricks for comparing fractions less than 1. So I think that's probably what it said. Okay, so let's get into this. So I really like something that I've been doing with you guys where I've been emphasizing that denominators are more like a label for something. And I've been emphasizing that a lot for the last couple of lessons, and I know that we doubled up on lesson 12 and had an extra day with it. So what I like though is that in this lesson, it actually does the same sort of thing. And the way that they do it is they say, imagine that you have 3 apples and you have 1 apple. Which is more, 3 apples or 1 apple? Well, 3 apples are more than 1 apple. Similarly, if I said that I had 3/4 versus 1/4, clearly 3/4 is going to be greater than 1/4. And then you could also write this mathematically. And that's what I've been saying to you recently, is I've been saying this is a label. It's a label that describes the size of each piece, of each part, of each fractional unit, would be another way to say it. So if I'm looking at this, I can see that these are each fourths. So I could say 3 of these pieces would be larger than 1 of those pieces. And I really started saying that a lot in lesson 13 when we were trying to pull out wholes out of fractions. So again, you can see that if I have 3 of this size piece, that's going to be more than 1 of that size piece. And in this case, the pieces' sizes are fourths. Okay, so if we know that, then let's compare some other fractions also. So that's just like an introduction to this concept of comparing things. And what we're doing here was we were really comparing fractions that have a common denominator, where the denominator is the same size. So if the denominator matches, such as fourths, then I can just say, well, how many of those pieces do I have? Let's do one more like that. Let's say that we had 2/7 and 5/7. So again, this is the size. Here I have 2 of those pieces. Here I have 5 of those pieces, or parts. So clearly having 5 of those, since they are the same sized pieces, is going to be larger. So that's one example of how we can compare fractions. We can take a look at the denominators, and if they are the same thing, then we can take a look and see how many of that sized pieces do we have in each of the fractions. Okay, so now let's say we wanted to compare 1/4 and 1/5. And this is going to be a quick review of like comparing things. So if I want to compare 1/4 and 1/5, what you should notice is that now my numerator is the same size. I'm just going to put a little line here. So now I have 1 piece for each of them. Well, the question is then, what sized pieces do we have? And you should be remembering that if I have a smaller number in the denominator, that means that my pieces are larger. So 4 is a smaller number than 5, which means that my entire thing, or my whole, has only been cut up into 4 pieces. Here it's been cut up into 5 pieces, so here the pieces are smaller. When you have more pieces, each piece is smaller. Let's do a quick sketch for that maybe. So if I have 2 tape diagrams that are the exact same size, or as well as I can do. This one's in fourths, this one's in fifths. You can see that fourths are much larger than fifths. So since fourths are larger than fifths, the alligator's going to eat the fourths. Alligator eats the larger number. Okay, so let's try another one of these where we have a common numerator, where the numerator is the same. So let's do 2/4 and 2/6. So now, even though my numerator is a 2, I can still do the same thing. I can still say to myself, well, which pieces are larger and smaller? Fourths, if I share a cake with 3 friends, so there's 4 of us sharing, those slices are much bigger than if 6 of us share the cake or the chocolate bar. So these pieces are going to be larger. So if I have 2 of these pieces, that's more than 2 of those pieces. So again, for this one, 2/4 is going to be larger than 2/6. Okay, so far it's been pretty easy. We had some problems where our denominators were the same. So we had some common denominators. And here we had some common numerators. But what if the common numerator isn't given to us? What about if we had a number like 2/8 and we wanted to compare that with 4/10? What could we do for this? Well, here's the thing. Even though the numerator is not the same, we could actually they're related to each other. Sorry for that little thing, but if I'm looking at these, I can see that 2 is related to 4. I can turn 2 into a 4. And sometimes you're going to see that that's a really easy thing to do. If I can make my numerators the same, if I can have common numerators, then it's very easy to compare these based on the denominators. And it's very easy for me to take this 2/8 and to turn that into a numerator with a 4. And remember how we do this? So if I want to make this 2 into a 4, I'm going to go ahead and put my 4 there, because I know it's easy to do that. And remember, we always write our original fraction, and then we show what we're doing with it. To turn 2 into 4, I have to multiply by 2. Another way to say that is 4 divided by 2 is 2. And whatever I do to my numerator, I have to do to my denominator, because 2 over 2 is just 1. So all I'm doing is multiplying by 1. And multiplying by 1, remember, it doesn't do anything. It doesn't change anything. We're just changing the sizes of our pieces. But the amount that we have is staying exactly the same. So 2 times 2 is 4. 8 times 2 is 16. And now I have equivalent fractions. I have 2/8 and 4/16. So now I have a common numerator. I can compare my 4/10 and my 4/16. So let me write that over here. So I'm comparing 4/16 and 4/10. I'm just moving him over here. So when I do that, I can see that my numerators are the same, so I have the same number of pieces. Which pieces are bigger? Which pieces are smaller? Well, if I share with 10 friends, those are bigger pieces, or if 10 of us share, those are bigger pieces than if 16 of us share. So this is going to be larger. 4/10 is larger than 4/16. But we don't write it that way for our answer. For our answer, we still have to use the original 2 fractions. So I know that 4/16 and 2/8 are the same thing, so I'm just going to rewrite it down here. I'm going to turn that back into the 2/8. So here I decomposed, now I'm composing, and then I can compare it to that 4/10, and it's going to stay the same as far as, which is larger, which is smaller. So I could also write that in the original 2 fractions between them. Let's do another one like this. I feel like we need another example that we can work with. So let's try one more. Let me get us a new piece of paper and slide us down and try and line us up. Okay, so I'm taking a look here now. Let's try 9/10, and let's compare that with 3/4. So again, I don't have common numerators, I don't have common denominators, but I definitely can see that I have something here that could work. I can see that 3 and 9 are definitely related. I know that 9 is a multiple of 3, or 3 is a factor of 9. And if I really quickly jotted my my multiples of 3, so 3, 6, 9, oh, there it is. I can see that I have a nice multiple going on here. So I'm going to turn 3/4, I'm going to turn that numerator into a 9. So I want to have 9 parts, or 9 pieces to compare it to. So let's take that 3/4 and let's show what we're going to do. So again, I want to turn my 3 into a 9. And so I need to show what I started with, my original equation. I'm going bigger, so I'm multiplying. And I can say 3 times what number gets me to 9? Or again, 9 times 3 is going to give me that number I'm looking for. And that's going to be a 3. So this was 3 times 1, 3 times 2, 3 times 3. 1 3, 2 3s, 3 3s. So 3 times 3 is 9. 4 times, we have to put a 3 there also. Numerator and denominator must match, so we're just multiplying by 1. 4 times 3 is 12. So now what I know is that 3/4 is equivalent to 9/12. Now I can compare my 9/10 and my 9/12. So since I now have the same numerator, a common numerator, I can just look at my denominator. Sharing between 10 people gives me bigger pieces than sharing between 12 people. 10 is a smaller number than 12, so these pieces are bigger. Here I have more pieces. So I'm going to make the alligator eat the larger number. 9/10 is larger than 9/12. But again, we don't write it like that. We need to still use this original equation. So I'm going to rewrite this as 9/10 and as 3/4. And it's still going to stay the same relationship because we only multiplied by 1. And now here we decomposed. I quickly composed it back to what it was. And it's the same thing. These are equivalent fractions. All right, so we have covered a bunch of scenarios. Let's do another one. Let's take a look at another kind of problem. So let's say that I have the fractions 7/10 and 3/5. So I'm looking at this, and my numerators are different, my denominators are different, and I definitely don't see a relationship between those numerators. 7 and 3, I do not see an easy way to turn 3 into 7 or vice versa. But I do notice something about my denominators. In this case, I can see that I have related denominators. I can see that very quickly. 5 and 10 are related to each other. And in fact, if I wrote multiples of 5, 10, oh, it's right there. So I can see that this is just 2 5s. So let's go ahead, and to make our lives easier to compare, let's take 3/5. And now, instead of changing and wanting to match up the numerator, I want to make my denominator the same as this denominator. So I'm going to go ahead and say, let's turn 5 into 10. So 3/5, we start with our original fraction. We're multiplying because we're going bigger. 5 times what number gets me to 10, or 10 divided by 5 will give me that number. So again, 5 times some number is going to give me 10, or 10 divided by 5 gives me that number, and you should get 2. You could figure that out however you want. If you want to make some containers or something, I'm good with that. But you should be practicing your fast facts. So now what I know is that 5 times 2 is 10, and whatever I do in my denominator, I must do in my numerator, so that 2 over 2 is the same thing as multiplying times 1. 3 times 2 is 6, and now I know that 3/5 and 6/10 are equivalent fractions. So now, let's compare these. Let's compare 7/10 and 6/10. And if I want to compare 7/10 and 6/10, I'm just bringing this number down, I can take a look and I can see that my size of my pieces is the same. Remember, this is just a label. So if I have 7 of this size pieces versus 6 of this size pieces, 7 is bigger, it's more pieces, so that's going to be a larger fraction. But again, I cannot leave it like that. I have to go ahead and I have to turn it back into my fifths. So I'm going to have 3/5 and 7/10. And again, 7/10 is going to be larger than 3/5 because these are equivalent fractions. So really quick, what I want to do is I want to quickly show you what this would look like, this relationship, on a number line. Because we are still trying to remember what our number lines look like. So I'm going to put 0. These are both fractions less than 1. So I can put my 1 over here. Now what I want to do is I first want to put in my fifths. Just because I'm really working with getting us comfortable with fifths. So let me see if I can do a good job putting in some fifths. Those are pretty good. So look, 1/5, 2/5, 3/5, 4/5, 5/5. And in fact, I'm going to go ahead and make all of these numbers green. So not numbers, but markings on our number line green, just to give it a little color. I guess you guys can't see it as well as I can. I apologize. Okay, so 3/5 would be 1, 2, 3. So this is where 3/5 would go. Now remember, fifths don't work with the half. The half would be right here, so 3/5 is between a half and 1, closer to a half. So now if I want to put in tenths, let me divide each of these in half, or into 2 pieces. And that's exactly what we did when we did our little multiplication times 2. So now I have tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since I have tenths, I can just figure out where is 7/10. 1, 2, 3, 4, 5, 6, 7. So clearly 7/10 is farther away from the 0 or closer to the 1, so it's the larger fraction. The other thing I want to point out on here is how 3/5 is equivalent to 6/10. Watch. I'm going to count my tenths. 1, 2, 3, 4, 5, 6. So 3/5 is the same thing, or is equivalent to 6/10, which was the equivalent fraction that we created for comparing. So we'd have the common denominators. So what we have done so far is that we have compared a bunch of fractions by either looking at their common numerators, if they had common numerators, or creating common numerators, or looking at common denominators, or creating common denominators. Those are the 4 things that we are going to be doing today when we are working in our problem set. So I'm going to jump us right into our problem set now. And we're going to do a bunch of problems in the problem set, and then you're going to finish it out for your work. But you're already going to have like half of it done. So it's really not that bad. Just for the record, for our work, we are not doing problem 6 for part of your work today. So we are going to jump in right with problem number 1. We're going to do a couple of these together. We're going to do all the circled ones together, and then you get to do all the not circled ones on your own, except for B, you don't have to do, even though it's not circled, but they did it for us already. Okay, so it starts out nice and easy. We're going to go back to like when we were doing the apples in the beginning examples. So here it says, compare the pairs of fractions by reasoning about the size of the units. Use greater than, less than, or equal to. So if I see 1/4 and 1/5, think about that. A 4th is going to be a larger piece than a 5th. Think about what those are. Remember, here's 1/4 and here's 1/5. When my denominator is smaller, it means I have larger pieces. So the alligator's going to want to eat that 4th rather than that 5th of a cake, right? So similarly, actually, I'm going to take back what I have written down here, and we are going to do this one, and we're going to do this one. I'm going to leave these 2 for you to do on your own. So let's take a look at B. So we have 3/4 and 3/5. So now when I'm looking at this, which one's going to be larger and which one's going to be smaller? So here I have 3 of those same size pieces, 3/4, and 4ths are again larger than 5ths. So if I have 3 of them, that's going to be larger than 3/5. And we can jot that down. So again, 4ths are larger pieces than 5ths, and I have a common numerator. So having 3 of the larger pieces is going to be more than having 3 of the smaller pieces. Okay, you can do C and D. Let's take a look at number 2. So number 2 is going to be really similar. It says compare by reasoning about the following pairs of fractions with the same or related numerators. And again, we're going to use greater than, less than, or equal to. Explain your thinking using words, pictures, or numbers. So let's take a look at this. So this says 3/5 and 3/4. So my numerator is the same for this one. I have a common numerator. And you know, I think you guys can see that, but maybe I can get us a little closer. Sorry. Let's try that. I think that works better for us. So I have 3/5 and 3/4. So my numerator is the same, so I just need to see which piece is going to be bigger. And again, fourths are going to be way bigger than fifths, so the alligator is going to eat the larger number. So if I were to describe this, I could say that fourths are larger than fifths. And that's a good reason. Right there, it's fine. I'm happy with that. If you can explain that to me, we're good. All right, so let's go ahead and let's look at D, because D is going to be a little different. So this is going to be a good review of some of the stuff that we were just doing. So it's 6/7 and 12/5. So you can see I do not have a common numerator. I do not have a common denominator. So what I want to do is I want to see, can I find a related pair of numbers, either in the numerator or in the denominator? So 7 and 15, I am not seeing it, but I'm definitely seeing a relationship between 6 and 12. And if I think about my multiples of 6, 6, 12, and there it is. It's right there for us. So it's pretty clear to me that that's what we're going to do. We're going to work with our numerator. So what I want to do is I want to take that 6/7 and I want to turn it into 12ths. So again, I'm going to write my original fraction. I know that I'm going bigger. And then I'm going to write what I want to turn it into. And since I would want to turn my numerator into 12, so I'm going to write that up here. So 6 times what gives me 12? Or 12 divided by 6 should give me that number, and that number is 2. So I'm going to have 2 over 2. 6 times 2 is 12. 7 times 2 is 14. So now I know that 6/7 and 12/14 are equivalent fractions. So now I can compare my 6/7, but I can do it as 12/14. And I'm going to bring my 12/15 down here. And now what I can see is that 14ths are bigger pieces than 15ths. So that means that having 12 of them is also going to be bigger than having 12 of the smaller pieces. So again, when your numerators are the same, just go and see how big are the pieces that you're comparing. Here they're bigger. So it goes like that. And again, what I could simply say here is that 14ths are larger than 15ths. And I'm sorry if I misspell anything today. I'm definitely thinking that my spelling's going to be off. 14ths are larger than 15ths. And you know what it is that like when I'm writing all the tenths, I know that I start to just combine letters really quick because I'm in a rush. Okay, 14ths are larger than 15ths. I'm sorry that my handwriting's like pretty atrocious too. It's just not my focus right now. Okay, maybe I'll make it a cursive day. All right, so for this one, again, I did not have common numerators. I did not have common denominators, but I did see that 6 and 12 were related numbers. Oh, but I forgot to do something, didn't I? Remember, we're supposed to rewrite it using the original numbers. So remember, 6/7 got turned into the 12/14. So I could write the 6/7 and compare it with the 12/15 again, and the 12/15 was smaller, so write it again that way. All right, so again for that one, we found that 6 and 12 were related numbers. Okay, so let's move on, and you'll be able to do C on your own, and I'm going to make sure I jot down the change that I made before I post it for you guys. Okay, so here, let me see if I can focus this in a little more for us. No, it's not going to work. Sorry guys, I'm trying to make it better, it's not working. It's like I can either get the middle clear or the sides clear, not both. Okay, it's because we're so close. All right, so it says draw 2 tape diagrams to model each pair of the following fractions with related denominators. What I want you guys to do, though, first is I want you to do it the way that we're doing it. I don't want you to model it first. I want you to model it after you figured it out, after you've done the math part, because I think that's going to be easier on you. And as long as you can show it to me mathematically, I'm going to be pretty happy. I'm not going to be as concerned right now about the tape diagrams, but I do need you to be comfortable with them as well. So we will go ahead and model it. But first, really just show me the math. So 2/3, 5/6. They do not have common numerators. They do not have common denominators. And if I look at the numerators, 2 and 5 are not related. But I can see that 3 and 6 are related. If I write the multiples of the smaller number, 3, 3, 6, oh, there it is, really quickly. It's the second number I wrote. So this is 1 3, that's 2 3s. So what I want to do is I want to turn that 3 into 6s. So I'm going to start with my 2/3, and I'm going to show that that's my original equation, and I'm going to show what I want to turn that 3 into. We're going bigger, so we're multiplying. We could be going smaller, but right now we're decomposing, making it into smaller pieces, which means there's more of them, so we multiply. Okay, so 3 times what number gives me 6? Well, we've already done that, I think, tonight. So 3 times 2, but I could have said 6 divided by 3 gives me that number. Whatever I do in the denominator, I have to do in my numerator, and 2 times 2 is 4. So now what we did was we took that 2/3 and we turned it into 4/6, which is an equivalent fraction. So now we can compare 4/6 and 5/6. So now the size of my pieces is the same. They're both 6. So having more of that size pieces is going to be larger. Now I can draw this in a tape diagram. So let's go ahead and do that. And what they're really going to be asking you to do for starters is to work with, sorry, my bad, is that they're going to want you to show how you divided those 2/3 up into 4/6. So that's the part that gets a little tricky. So don't stress over this part. Let's do it. Let's learn it. But I really want you to focus on being able to do it mathematically right now, because we've been doing so much of these tape diagrams. So here's one whole, and I'm going to have to make sure that my one whole is the same for both of these. Now I'm first going to model 2/3. So I'm going to go ahead and I'm going to try my best to make this thirds. And then, I know that first one's a little off. Let me grab my pencil, which I know I've tucked over here somewhere. And I'm going to shade in 2/3. So now let's go ahead and let's do the 5/6. So if I'm going to do 5/6, first I have to cut this into 6 pieces. 1, 2, 3, 4, 5, 6. And now I'm going to go ahead and shade them in. And then it becomes really clear to see that 5/6 is larger than 2/3. But we have to be able to compare them by splitting these up or decomposing these into their 6th. We want to model what we did. So since we multiplied times 2, it means that we cut each of these up into 2 pieces, or split them, or decompose them. And so I'm going to go ahead and I'm going to put that dotted line in there. So now you can see that I turned it into 1, 2, 3, 4, 5, 6 pieces, and we have 6. So you're seeing here that we have our 6th, and you can again see 4/6 was less than 5/6. Okay, so I'm going to let you do B on your own. I'm going to do C with you because I know C is going to kind of catch your guys' attention, and you guys are going to be like, whoa, wait a second, what's going on here? We have 1 3/4 and we have 1 7/12. So just looking at this mathematically, what I can say to you is that the 1s are the same. So all that I'm really comparing is the 3/4 and the 7/12. I don't even really have to worry about that 1. I can just focus on my 3/4 and on my 7/12. So mathematically, I'm going to do that. I'm just going to compare 3/4 and 7/12. And I see that my 3 and my 7 are really not related, but I can see that my 4 is related to my 12. If I were to write my my multiples of 4, I would have 4, 8, 12. And there you have it. So remember, take the smaller number and write the multiples of that smaller number. Okay, so if I want to take my 3/4 and turn it into 12ths, I'm going to do that mathematically. So I'm going to write my original fraction. I'm going bigger, so I'm multiplying. And what I know is I want to turn my 4 into 12, so I write the 12 in. I don't write anything in the numerator. We have to figure that out. 4 times what is 12? Well, I can see it's 1 4, 2 4, 3 4s. Or I could say 12 divided by 4 gives me 3. Whatever I do in the denominator, I do in the numerator. 3 times 3 is 9. So now what I know is that 3/4 is equivalent to 9/12. So I'm going to write that. And then I'm going to bring this guy down. And now I can see my denominator is the same, which means that the size of my pieces is the same. So which one's larger, having 7 or 9 of those size pieces? 9 is clearly going to be larger. When your denominators are the same, you can compare your numerators. Which means that 3/4 is also going to be larger than 7/12, which means that having 1 and 3/4 is going to be larger than having 1 and 7/12. Does that make sense? I hope it does. So let's now go ahead and do those tape diagrams. So for the tape diagrams, here's where it gets really interesting. What we're going to do, and we could even do this on like number lines, just going to give us a little bit of room over here. So what you're going to have to do is you're going to have to draw, though, 2 parts to each of these tape diagrams. So I'm going to go ahead and do that. And then I'm going to do this one, and I'm trying to make them as even as I possibly can. Okay. So, ooh, you can't even see all of them. They went a little too long. There we go. So pretend they're perfectly even. They're actually on the page even. It's just the warpness of the camera. Well, maybe not perfectly even, but close enough. Okay. So again, on top, I'm doing over here 1 and 3/4. And down here, I'm going to do 1 and 7/12. But remember, 3/4 is the same thing as 9/12. So first of all, I can just go ahead and I know that this whole thing is 1